Hello everyone. Today's LitCode challenge is get missing positive number. Okay, let's do this together. So the question is, where will be given array of positive numbers sorted in a strictly increasing order and an integer k. And we have to find the kth positive integer that is missing from this array. Okay. So means that if we are given this array, then k is array is this array only contains positive integers. It means that the array, it starts from 1 to 1000. I mean, it doesn't contain negative number, it doesn't contain 0. That is what it is saying, and it is sorted in strictly at increasing order. It means that this is a sorted array, and this is sorted in not only increasing, but there is strictly word also. It means that uh, there cannot be 2 to 3, right? Because it is strictly increasing. It means another number strictly increasing means that I plus I is greater than array I. It is not even equal. If it is equal to like this, then it is, we cannot say that it is strictly increasing. Okay, so we answered the question. This sentence, now we have to return the kth positive numbers that is missing from the array, right? So let's see. In this question, kth positive number, right? So if we have to find the number, so what is the first missing number? What is the first number that is missing here? That is the 1, right? 1 is not here. What is the second number that is missing here? 2 is here, 3 is here, 4 is here, 5 is not here, right? So second missing number is 5. What is the third missing number? After 5, 6 is not here, right? So third missing number is 6. What is the fourth missing number? 7 is here, 8 is not here, right? So 8. What is the fifth missing number? 9. So answer is 9. Okay, yeah, this is pretty straightforward, I think. So how do we find what is the solution? I think that what we can do is we can just start from k is equal to our k count, let's say, because k is already here. So we can start from k count is equal to 0, and so when k count is equal to 0, then norm, so we will start from norm is equal to 1, and we will check if, so we are traversing the array, right? We will check if 1 is here or not. 1 is not here, right? So it means algorithm is, this is the algorithm. So if norm is not equal to array I, then what would we do? So number 1 is not equal to, we start with norm is equal to 1 and k count is equal to 0. So if it is not equal to array I, then then it means that 1 is not equal to that, right? So it means that I need to increment k count plus plus and norm plus plus as well. So now we will look for, so I'm doing k count plus plus because since 1 is not here, now we know that 1 is not here, right? So we will say that k count is 1 because we know that first missing number is 1, right? Now we will see for 2. So that's why we're incrementing count 2. So 2 is equal to, 2 is here, right? Okay, 2 is here, so we will not do anything. We will, otherwise, I mean, if norm is equal to array, otherwise we will just do I plus plus and check again. Is norm to, we will do I plus plus and norm plus plus as well because we would want to check another number. So 3. So again 3 is equal to, 3 is here, right? So we would do I plus plus and norm plus plus again. So 4 is also here, right? So we would do num plus plus and I plus plus again. So 5 is not equal, right? So 5 is not here. It means that the second positive integer that is missing is equal to 5, right? So we would increment k count plus plus and we would increment k count plus plus and we'll increment k count plus plus and also check if k count plus plus, if it is equal to k, then we'll return num, right? Because we know that the second number that is missing is equal to 5. But if it is not equal, then we will increment, we'll look for other number 6. If 6 is also not here, right? So we would, it means that the third number, third missing positive integer is 6. So and we are not looking for 3 is not equal to 5. We are not looking for third positive integer number. So we will look for another number 7. 7 is equal, right? So we would increment I now. Since it is equal, so we would increment 8 as well. So 8 is not equal to this number, right? So it means that fourth positive missing number is equal to 8, right? And now we look for, since we are not looking for fourth positive missing number, we will see if another number is what is missing. So 9 is also not equal to, right? So we will, so it means that 9 is the fifth positive missing number. So yeah, we will do it until we find k count is equal to k, right? So first of all, let me code this. So let k count is equal to, let k count is equal to 0 and let norm is equal to norm will start from 1, and for let we'll do it until we'll do it until I is less than array dot length, until I is less than array dot length we'll do it. So we'll check if array I, if it is equal to the number, right? So if array I is equal to number, then it means that we will look for another number. So we would have to increment this one and norm as well. But if it is not equal, then it means that we have found the missing number. We have to increment the k count and then check if this is equal, k count equals to k, then we would return the num, right? Otherwise, if it is not equal, then we have to see, it means that we have to check for, we have to find on another number that is missing. So we will increment norm and check if that is the missing number, if that is also missing or not at next time. So at I is equal to norm, not okay, yeah. And at last, yeah, if k count is equal to k, then return norm. So can there be situations like nothing is missing, right? 1 2 3 4 and k is equal to 8, then what should we do at this point? So a is already in a. In this case what would happen is there will be k count is equal to 0 and norm we will start from 1. So norm will be equal to I, then we will increment 2 also. So this is also equal 3, this is also equal 4, this is also equal. Now we'll get out, and I, this is also equal. So if this is also equal, then I plus plus and norm plus plus 5, right? So yeah. And what if we are getting out of the loop, then what would you do is while k count is, what we can do is, I think, since we have got out of the loop, and we want to find k is equal to 8, right? So it means so what would be the answer in this case? The answer in this case would be 5 5 6 7 8 9 10 11 12 1 2 3 4 5 6 7 8. The answer would be 12, right? So I think the answer would be like 4 plus 8. 4 plus 8, 8 9 10 11 12, yeah. So I think the answer would be, if we come out of this loop, then it means that the answer would be 4 plus 8 minus k count, because suppose there is no one, okay, then it means that 1 is already here, right? So it means that we have already found one number. That is why, because 4 plus 8, I mean, what I mean to say is 4 5 6 7 8 9 10 11 12, we need to find the kth number. What we can do is, we can just say k minus k count. So if we have found one count already in this case, then we would need 7 more, right? To find 7 more, we would have to add 7 with 4. 7 8 9 10 11. Yeah, so it would be written k minus k count plus array last, array dot length minus 1. Because k minus k count would give us a value that it would give us the count of the remaining positive numbers that is needed, and if we add the last value to the positive numbers that is needed, we will get that value. So here also we will need, suppose if this value is just 1, it means that we need one more positive integer, right? So it would be 5. 4 plus 1 is equal to 5. Yeah, I think this would work. I'm not sure. Shit, what happened? I is not defined. Let I is equal to 0. Wait, what?